$10,577. A number so small for a product so advanced that it almost feels like a typo. Yet it isn't. That price tag belongs to the Tesla Model 2, a vehicle that has completely flipped the automotive world upside down. And it isn't just because of affordability or clever marketing. The shock comes from how many hidden engineering breakthroughs Tesla managed to pack into a car that costs less than most used gas vehicles on the US market today. People knew Tesla was pushing the boundaries, but nobody expected the company to quietly test features that normally belong to high-end research prototypes or $500,000 specialty programs. Suddenly, a budget EV is carrying tech that feels like it came straight from a futuristic concept car. The leaks showed 3 previously unseen features in testing, and each one is more disruptive than the last. A nearly indestructible polycarbonate windscreen, a thermal loop frame that changes how cabin comfort is engineered, and a weight-adaptive floor plate that dynamically adjusts the vehicle's behavior in real time. The combination of these technologies has sent shockwaves through the US automotive industry. Car enthusiasts, engineers, analysts, insurance companies, everyone is feeling the impact. For people who follow the EV world, the Model 2 was already highly anticipated. But nobody expected this level of innovation in something priced just above 10 grand. And if you're tired of the same repetitive EV news, the same recycled stories, and the same predictable narratives, this one is refreshingly different. The details are new, the insights are updated, and the implications are bigger than anyone predicted. This is where the disruption really begins. When it comes to the polycarbonate windscreen, most drivers don't think much about the material protecting them from the outside world. But the truth is, drivers in states like California, Texas, Florida, and New York deal with road debris, environmental stress, and temperature swings that put enormous strain on traditional laminated glass. Microfractures, surface pitting, cracking along the edges, stress-induced failures have always been an unspoken part of car ownership. Glass looks great when it's new, but over time, its limitations show. Tesla decided to reconsider the entire purpose of a windshield. Instead of sticking to the industry's comfort zone, Tesla swapped out traditional glass for a multi-layer polycarbonate laminate that completely resets expectations for durability, safety, and efficiency. The material ranges from roughly 0.27 to 0.33 inches. But the thickness isn't even the real achievement. The engineering lies in the layer structure. The first layer is a flexible, energy distribution surface that spreads incoming force across the entire panel instead of letting the impact concentrate in a single weak point like typical glass. Beneath that, a UV-stabilized structural core provides rigidity without the brittleness that plagues glass under heat stress. And then a heat-reflective interior coat reduces cabin temperature before the air conditioning has to lift a finger. Glass doesn't do any of those things. It just sits there, waiting to crack. What people don't realize is that traditional laminated windshields are fighting a losing battle from day one. In most American climates, glass goes through 80 to 120 heat-cold cycles per year, enough to create microfractures that weaken the structure. That's not even extreme weather. That's just the sun heating the surface during the day and temperatures dropping at night. Over the years, the cracks accumulate. But the polycarbonate windscreen Tesla engineered can endure over 500 cycles, while maintaining structural integrity. That solves heat expansion in Texas, sun-induced warping in Florida, freezing contraction in New York winters, and the high-velocity debris issues along major highways like California's Interstate 5, where rocks and gravel constantly chip and crack traditional windshields. When glass gets hit by gravel at 55 miles per hour, the result is predictably cracks, chips, or produces a spiderweb fracture. But when that same debris hits Tesla's polycarbonate design, the outer layer flexes, absorbs, and distributes the force. Instead of fracturing, it pushes the energy sideways, and the debris simply bounces off. The difference isn't subtle, it's a different category of impact response. The performance data behind this is almost ridiculous. Impact resistance increases by more than 160 times compared to tempered glass. The polycarbonate windscreen can absorb between 150 to 180 foot-pounds of force without failing. That's the kind of energy that would shatter traditional glass instantly. What makes this even more impressive is how the flex characteristics have been tuned. A deflection tolerance of roughly 0.08 to 0.09 inches during a high-speed impact is enough to dissipate energy without distorting the driver's view or compromising the frame seal. And because the material is lighter, roughly 6 to 8 pounds less than the equivalent glass panel, the car gains a surprising efficiency boost. Reducing front-end inertia, even slightly, translates to smoother acceleration in city driving and more controlled deceleration. Over a year of typical urban driving around 12,000 miles, the efficiency gain is around 2.9%. That means better range in stop-and-go conditions and lower energy consumption overall. Then there's thermal behavior. Traditional glass absorbs heat like a sponge. On a sunny day in states like Arizona, Nevada, or Florida, a windshield becomes a massive heat source, forcing the AC system to work harder. But the heat-reflective interior layer of Tesla's polycarbonate windscreen cuts cabin temperature by 14 to 20 degrees Fahrenheit before climate control even engages. That translates to a 9% to 12% reduction in HVAC load. In an EV, that matters. Every watt saved on cooling is a watt preserved for driving. Tesla didn't just design a windscreen, they designed a structural thermal component. In controlled debris testing, the results were staggering. At 55 miles per hour, the polycarbonate windscreen avoided cracking in up to 92% of tests. Traditional laminated glass didn't come close. Even more impressive, long-term UV exposure tests in southern climates showed 30% slower haze development compared to uncoated polycarbonate. That means the windscreen stays clearer for longer, resisting the usual yellowing or clouding that plastic materials sometimes face. Freeze-thaw tests were even more dramatic, over 1,000 cycles with no layer separations or delamination. That level of durability places the Model 2's windscreen closer to aerospace-grade performance than automotive-grade standards. These aren't theoretical numbers. These are certification-level results backed by data. But the real earthquake hit the insurance industry. Over the last year alone, there were more than 3.8 million glass-related insurance claims in the U.S., each costing between $350 and $480 for a replacement. Polycarbonate windscreens eliminate 70% to 80% of the common brake scenarios. That disrupts actuarial models that have been stable for decades. Fleets in California and Florida already reported reduced downtime from debris, damage around 40% faster return to service when using polycarbonate panels. For fleet operators, that's money saved. For consumers, that means fewer replacements and fewer insurance claims. And for Tesla, it's a strategic win. A durable car is a cheaper car to own. As more details leak about these experimental features, it's becoming clear that Tesla isn't following automotive tradition. They're engineering the Model 2 like a piece of long-term infrastructure, not a disposable consumer product. If the windscreen alone carries this level of innovation, imagine what the thermal loop frame and adaptive floor plate bring to the table. This is only the first piece of the story, yet it already shows why the $10,577 Model 2 has shaken the U.S. market. Tesla has redefined what's possible inside a budget EV and has forced the industry to rethink what a low-cost car can actually be. The disruption is only beginning. And every new leak proves that the Model 2 is not just another affordable EV, it's a blueprint for the future of American transportation. And if this is how Tesla approaches something as simple as a windshield, it's clear that the rest of the vehicle will carry innovations that nobody expected in this price range.